Good morning. Let us see today what is solubility of salt. What is solubility product of salt? How solubility product is determined, calculated from solubility. How solubility is calculated from solubility product. There are several problems asked based on this formula. Okay. So let us see what are the different types of salts. Solubility of salt. There are two types of salt. Okay, freely soluble salts, for example, sodium chloride, potassium chloride, they are freely soluble. Such salts are freely soluble. They are also called strong electrolytes. And there are some salts which are sparingly soluble. There are salts which are sparingly soluble. Okay, for example, silver chloride, barium sulfate, silver iodide, silver bromide, etc. They are soluble in very little quantity. They are very less soluble in water. Okay. So let us now see what are unsaturated solution and saturated solution. Okay. Now when you add salt, for example, when you add salt, freely soluble salt to water, okay, it is soluble. It will be soluble. More and more salt will be soluble. Okay. And what is unsaturated solution? Is one in which more salt can be dissolved. This is unsaturated. For example, this is unsaturated because more solute, more salt can be dissolved. Okay. If you go on adding at one point of time, the salt won't be soluble. For example, the salt won't be soluble. The salt will precipitate. The salt will deposit settles at the bottom. Now this is called a saturated solution. This is unsaturated solution. This is saturated solution. The saturated solution is one in which no more solute can be dissolved. Here, more solute can be dissolved. Here, it is opposite. No more solute salt can be dissolved in saturated solution. Now, for example, you can prepare saturated solution for highly soluble salt and sparingly soluble salt. Okay. In the case of highly soluble salt, more salt is added to prepare saturated solution. For example, in the case of sparingly soluble salt, a pinch of salt is required to prepare the saturated solution. Okay. Now let us see, in saturated solution there exists a dynamic equilibrium. Remember, in saturated solution there exists a dynamic equilibrium between the undissolved solute, salt and soluble ions. There is an equilibrium between the undissolved salt and the soluble cation and the anions. Okay. For example, in the case of sodium chloride, in the saturated solution, there exists an equilibrium between sodium ion, sodium chloride solid, and the sodium ion and the chloride ions. Okay. Therefore, this is an equilibrium process. We can apply the chemical equilibrium principles, applying the law of mass action, K equal to activity of Ag plus activity of Cl minus divided by activity of AgCl solid. Okay. For silver chloride, the solubility is very less. Therefore, the concentration of Ag plus and Cl minus ions, are very less. Therefore, the solution is very dilute. For dilute solution, activity of ion is equal to concentration of the ion. For example, activity of Ag plus equal to concentration of Ag plus, activity of Cl minus equal to concentration of Cl minus for dilute solution. Okay. Because the concentration of Ag plus ion and Cl minus ion are very less because of sparingly soluble salts. Okay. Now let us cross multiply this AgCl, concentration of AgCl solid, that is activity. We know that the activity of solid is taken as unity. The activity of solid is taken as unity. Therefore, the concentration of solid is taken as unity, and therefore this constant is Ksp, the solubility product equal to Ag plus and the Cl minus. Now, this is how much is soluble is S. For example, S mole is soluble. What is solubility now? It is the maximum. It is defined as the maximum amount of solute that can be dissolved in 1 liter of solution. 1 liter of solution. Its unit is moles per liter. Moles per liter. Okay. So suppose S is the solubility. Yes, not solid. This is solid. S is the solubility. Degree of dissociation. Okay. S is the solubility. Therefore, Ag plus will be there. S moles of Ag. S moles per liter is soluble, for example. Then S moles per liter Ag plus ion will be there, and Cl minus S moles per liter Cl minus ion will be present in the saturated solution. Okay, therefore at equilibrium S into S. Therefore S square, what is the unit of solubility? Moles per liter. Therefore mole square divided by liter square. Therefore Ksp equal to S square. S equal to square root of Ksp. Suppose you are given, remember, suppose you are given the solubility product of the salt. Then the solubility of the salt and the solubility of the silver chloride can be calculated by taking square root of the solubility product. Let us consider another example, aluminum trioxide, which is sparingly soluble salt, and it is a weak electrolyte. A part of the salt is only soluble. Therefore, there is an equilibrium between the ions and the undissolved salt. Al3 plus 3OH minus S moles per liter of aluminum hydroxide is soluble. Therefore, S, and 1 mole gives 3 moles. Therefore, 3S. Ksp equal to concentration of Al3 plus OH minus cube. Okay, therefore S aluminum 3 plus concentration, and 3S OH minus and concentration 3S whole power cube. Okay, therefore cube. Therefore 3 cube equal to 27 into S power 4 mole power 4, because mole per liter cube. Therefore mole power 4 divided by liter power 4. S power 4 on rearranging, S power 4 equal to Ksp divided by 27. Therefore from Ksp the solubility can be determined. Okay, from Ksp the solubility can be determined. In general, for example, Ax plus By gives Xa y plus, okay, y b x minus. Therefore, for example, S moles is dissolved. S moles of let us consider S moles of the salt is soluble. Therefore, Xs, Ys moles are present, ions are present. Therefore, Ksp equal to Xs to the power x. Okay, here similarly see, and Ys to the power y. Therefore, x power x, y power y, s power x plus y. Okay. Now let us see a problem asked in IIT JAM in competitive examination. The solubility of lead iodide in 0.1 molar Ka is dash into 10 power minus 7 moles per liter, or moles per liter. Ksp equal to 7.1 into, you are given Ksp and you are asked to find the solubility of lead iodide in 0.1 molar Ka. Now, what are the equilibrium present? Now, see what are the equilibrium present. Lead iodide is sparingly salt. It is partially ionized to give lead 2 plus and 2I minus, and S moles of lead ion is present, and 2S moles of I minus ion is present. Okay, and similarly it is present in 0.1 molar Ka. Therefore, Ka is strong electrolyte. It is completely dissociated to give K plus and I minus. 0.1 molar. Therefore, K plus is 0.1 molar. I minus is 0.1 molar. Now you see, I minus ion is common with the lead iodide. Therefore, due to common ion effect, more I minus ion will be there. Therefore, the equilibrium, more product is added. Therefore, the equilibrium will shift towards left. Therefore, the solubility is decreased. The solubility is less in the presence of potassium iodide due to common ion effect. Due to common ion effect, the solubility of lead iodide is decreased. Okay, this solubility is suppressed, decreased due to common ion effect. Therefore, in the you substitute Ksp equal to lead 2 plus I minus whole square. Now lead is S and I minus is 2S. I minus is 2S plus C because lead iodide is in 0.1 molar Ka. Therefore, plus 2S plus 0.1 molar that whole square. Okay, whole square. Because the lower due to common ion effect, the solubility is very less. Solubility is around 10 power minus 5, 10 power minus 7. Therefore, 0.000 solubility. Therefore, it is assumed that 0.1 is very much greater than 2s. Therefore, S into this is 0. This is negligible. 2s is negligible because of common ion effect. The solubility is decreased. It is assumed to be very less. Therefore, S into 0.1 whole square. Therefore, Ksp on substituting and S equal to you will get 7.1 into 10 power minus 7. 10 power minus 7 moles per liter. Okay. So similarly, there will be several questions in competitive examination. They will ask definitely one question from this solubility product calculations. So please understand and write down the formula in your notebook. Thank you for watching.